Fluid Mechanics 1 SEM M2313. In this slide, we will see one common example on how to solve using Buckingham pi theorem. So the question will be given like this. The friction factor F depends on the various quantity that affect the flow, such as the density of fluid, dynamic viscosity of fluid, fluid velocity, pipe diameter, and pipe inner wall roughness. So first, when you read this question, what you need to do is you need to convert this statement into a mathematical expression. So the mathematical expression can be written as this one. F here is the friction factor, depends on the sentence here. So means from the question, it seems that we want to calculate or we want to determine what is the friction factor. So here, friction factor will become the subject in this Buckingham pi theorem. So and then we put the subject as a subject here in mathematical expression. So we have F is, and the alphabet F here means the function of. The function of. So means that you need to read this mathematical expression as friction factor is the function of rho, mu, v, d, and e. So all of these parameter is actually mentioned in the question. So this is the velocity, pipe diameter, and pipe inner wall roughness. So please be careful when you want to solve Buckingham pi theorem. Please do not add another parameter. Just use parameter that mentioned in the question only. In some textbook, they will replace the symbol F here to not confuse with other F. For example, in this question, we have two F. One is friction factor, and here is the symbol for the function of. So in some textbook, they will replace the F here with the symbol of phi. So this is the phi. So but we read these two statements as this one. Friction factor F is the function of rho, mu, v, d, and e. Next, what you need to do is you need to determine the MLT term for all the parameter. So according to this question, we have 6 pi term. So we list all the pi terms here. So similar with the arrangement at this step. So we arrange according to that step. So we have 6 pi term, and then we write all the MLT term for all the parameter here. So the friction factor here is the dimensionless. So we will write as M0, L0, and T0. So divide all pi terms into geometry, kinematic, and dynamic groups, except for friction factor, because friction factor is the main subject for this function. So what you need to do is, so you just left the main subject alone. So and then you need to divide all the parameters except the main subject here into their own groups. So please remember that we have 3 types of group, which is the geometry, kinematic, and dynamic. So we go for the first group, which is the geometry. Normally for geometry, the unit is L. So means everything that have L only will be grouped as geometry. So in this situation, we have diameter and roughness, because the unit is length. And then for kinematic here, you just imagine about the velocity. So we have velocity, we have acceleration, we have gravity, and so on. Okay, so in this case, we only have velocity. So and then in dynamics group, So everything that not grouped as geometry and kinematic will be embedded, will be inserted into dynamic group. So in this question, we have rho and mu as the dynamic group. So and then from these three groups, we need to determine the repeating parameter. So what is the repeating parameter? So repeating parameter is the most influence parameter in each group. So for example, in geometry here, we have two parameters, the diameter and the roughness. So we have two parameters. One of them must be the repeating parameter. So you need to think whether the diameter or the roughness, which one is the more influence the flow. So here we will take, normally we will take the diameter as the repeating parameter, because if the diameter keep increasing, so if the diameter become larger and larger, the surface roughness maybe not influence the flow anymore. So means that the diameter is the most influence parameter for geometry. So and then for kinematic here, so because we only have one parameter, which is the velocity, so we just take the velocity here as the repeating parameter. And then in the dynamic, we have rho and mu, and usually people will take rho as the repeating parameter. So and then you just separate the repeating parameter and non-repeating parameter as shown in this table. So means that if D here is the repeating parameter, so you need to take E as the non-repeating parameter. So V, we have no choice, so V will become the repeating parameter, and there is no non-repeating parameter. It is okay to have no repeating parameter here. And then rho will become repeating and mu will become non-repeating parameter. So for repeating parameter here, because we only have three groups, so means that the maximum numbers for repeating parameter is 3. There is only 3 or less repeating parameter. It can be 2 and it can be 1, but it cannot be more than 3. So if you get 4 or 5 repeating parameter, you are totally wrong. So this is the something that you really need to know. So and then you need to develop the pi term. So how to know how many pi term we need to develop? So the equation or the idea is very simple, which is the number of pi term is the number of total parameter minus the total repeating parameter. So in this case, we have total 6 pi term. So and then we have 3 repeating parameters. So after you deduct 6 minus 3, so you will get 3 pi terms. So these 3 pi terms is, you need to develop 3 pi terms as this one. So how to develop this one? The basic idea is you just use non-repeating parameter. You multiply with the repeating parameter with certain value of power here. So it will become like this. For pi term number 1 here, pi 1, so we take the subject, which is the f, and then we multiply with rho vd, because here we have rho vd as the repeating parameter. So we take all of them, okay, but you need to write as rho with the power of a, v with the power of b, and d with the power of c.